Really, I'm so grateful for top management.
Surface area, they could fall here and mix, but this layer of mesh separates them. Now these wood chips contain microorganisms. We have chosen fungi because fungi can work under low pH and varying moisture content. The moisture content required here is above 40%. So that will need maintenance. And also we require rodent control because rodents can come and make a habitat out of these wood chips. Yes. So now, how the microorganisms work is that they attach and grow on this bed of wood chips. And once the polluted air comes here, they use the polluted air as sources of carbon and energy, and then they leave the clean air. So this is where the clean air comes from. And yes, that's basically our project.
What is the source of polluted air?
This is still a model.
What air do you want to purify?
This polluted air can come from farms, sewage treatment plants. The good thing with this, the advantage of the biofilter is that it works on a wide scope. It filters not only undesired foul air, but also air that's polluted with volatile organic compounds, like those ones which are emitted from paint factories. Yes, those ones are dangerous to our environment and also to us. So this is a model of how it's supposed to look like. This is an industrial building, and this is where our biofilter is located. Here in this model, we have covered the top because it's at the top of the roof and we don't want rain to flood it and spoil the integrity of our biofilter. So after covering the top, we have connected it to a pipe which will emit the treated air.
So that is more like the industrial.
Yes, the industrial applications.
But can it be modified for a car?
Yes.
No, I'm just saying the concept.
So we keep working with the idea. So continue with that.
All right. Thank you so much.
It's a very good thing.
Good morning once again. So this is a pick and place machine. Basically, for those who do ICT, I do believe you make boards. So this one is designed to simplify for you at least the strains you have. Because now, how you may ask how does this work? Basically, you bring your different small components because it deals with small components you're dealing with. You come, you pour them here on the board. Now, if this is the board itself and it's blank. You come. Now this one is more of manual, but it's supposed to be, we are advancing it to make it automatic. So it uses a suction vacuum method, whereby as you see that I've placed in on my power, but as you try to feel it, you can feel that touch that it is sucking. So once you can touch it here.
What is it sucking?
It sucks the component and it attaches to that very pin. So after getting attached there, you are supposed to move it and then put it to where you want it to be. But now, a few components are missing because we are supposed to have a camera connected to an app, and then we screen it. Because this is supposed to be more of automatic, so that you just move it as you're viewing the screen, because they are small components. So once you bring it, you put here your component. After placing there your component, all components are supposed to be filled up. Once they're all filled up, you move it back again this side and get a spray, just a spray, and then you spray the components. Other than soldering, that you put your components, you're going to turn and start soldering again, but that spray is supposed to attach all the components automatically. That's how basically it does.
So in the layman's language, if I'm coming from Chikubo,
yes,
how is it useful to me?
Now, for you, if you're designing your board, if you're designing your board, first of all, if it's automatic, these arms will be moving automatically.
Now what I mean,
yes,
even that board and whatever, how is it useful to
Day-to-day life, it helps in board designing. Basically, those boards that are in phones, boards that are for televisions, those ones, and yes, and it does them in a shortest period of time compared to what is around right now. You get the next trainers, you get that individual component so that you solder it. But this one will try to simplify it within a shortest period of time.
So at one point this one will be automated so that...
Yes, because it mainly lacks 4 things: the camera, everything. Each, as long as it's a board, electronic board, is supposed to do that. Yes.
Some modifications, like we have a camera. If you have a camera here, and for the camera, it will be helping you to view very well. We are going to pick the chip, and then we are going to press it. You get, yeah. So it can easily help you. Like you just view it through the camera. You can connect the camera to the, let's say, monitor, or even your phone or a laptop. So you view it, you pick it, come, press it on the board with the aid of the camera.
So where is the pressure that is sucking coming from?
So it's from
the
suction motor pump.
It's this very one.
It is generated there.
Yes.
Great, thank you very much.
Design it to a proper way, because when you look at the blades of this machine, they are made of iron and they are thicker that almost cut everything from the banana. So if we improve this and make it circular, in that it can achieve any angle of the banana, and this is the design of the machine that's going to be made. It's having a locking the peelings and not the flesh, and that decreases the wastage of food and so on. Then we have a collection point, so when the bananas are cut, here when you look at this machine, it's falling down, and this food safety is not being taken as a priority. But there we have that pipe that after the blade has cut the bananas, it moves through the pipe into a collection point, let's say a saucepan or a box and so on. Then at the sides, the peelings are being collected, because when you cut them, the peelings go to the sides, then they are being collected from down at that down collection point. You can put a box or a cover, and it is still going to be modified. The dean said by March there has to be already an improvement on this. Yes, because last year they won a grant of about 6 million of this machine, so they wanted by May there has to be already an improvement, and we are going to consider that. We also considered, because when you look at the matoke, look at my hand, it's already having a lot of sap. But when we have this matoke, you cut here, cut there, then we have a collection, like you first put a point like other sides, then you put water. Because when you put matoke into water, the sap decreases. Yeah, by the time you're putting it into the blade, it's going to reduce the amount of sap you receive on your hand. So by the time the peeling is done, the matoke is clean and your hands are also clean. Yes.
So what motivated you to invent this?
I've seen what you brought.
Yes.
So you can put in a fresh one.
So when you look at this, you have no option.
Since whenever this one cuts, you can see that it cuts in different shapes, which are not compared to what a normal person. If at all is peeling, it comes out in a different way. We are trying to see that first of all, the blade is circular, because the bananas are already circular. We are trying to see that the blade is circular. Then we are trying to see, since some are small, others are big, to make it adjustable. And then after, if at all that's it, how are we going to differentiate the hard part and the inner part, so that if it's cutting, it only cuts it cuts off the flesh, leaving alone the matoke. So that's what we are trying to see, if at all can we possibly advance this to something better. And then also maybe after cutting, we are putting here like a trailer, so that it just helps in after cutting all those matoke, they can easily get off, rather than after putting this side and then you start waiting for them from this other side.
Okay, thank you very much.
Yeah, what maglev means is magnetic levitation. Yes. So imagine a train that does not run on tracks, but it floats on top of the track, and it is pushed. Pardon? Yes. Yeah, this is a train, a maglev train. It is magnetically levitated. What this means is that for it does not run on it touches the track. For it floats above the track. So it is repelled up by magnets and then also pushed and guided by magnets. And this is a simulation and reverse engineering of the pre-existing maglev system. So what we have put here, this is the cross-section. This is what we have wound in terms of the engineering bit. So what you see here is what is used for levitating the train. We have decided to wind, these are what are known as electromagnets. Now electromagnets are similar to this kind of magnets here, you see here. They attract, right? And they can also repel each other. So these are the unique properties of magnets that we are going to be utilizing here. But due to certain issues, we shall only be using some bit of demonstration. So what you see here, this is for purposes of demonstration, to show you that these are the principles behind the maglev train system. So what you see here, these are the tracks for the maglev train system. And what this is that this is where the train floats. The train does not touch the track, but it floats above this track. And how does it do so? When you get a hold of this, you can have this. Yes, this is a magnet. Now this magnet, when I bring this on top of it, you see that you feel a force, right?
Yes, it is moving.
The force is trying to push the magnet away. It's trying to push the magnet away. So that is what we are trying to utilize here.
Oh, to move, to see that it can move.
To be levitated up. This truck here is going to be powered by this power supply, and it's going to be pushing up our train. So this is the simulation of the train. It also has its permanent magnets on top of it, like at the bottom. So when you place it on top here, and you power on this truck, it's supposed to repel this train up. Now that is, you have achieved the levitation, yes? So the train is now floating above the truck. But the train is still just floating, it is not moving, not so? You need it to move. Yes, now that also we have to use electromagnetism. Now I have a small simulation here. We could not make all the coils because of short time, but the same way we want this, the same way we want that. Okay? So when you have a coil of wire around like a magnetic material like this, you produce what is known as an electromagnet. And to demonstrate that, I can power on this simple circuit here. So this circuit is now in operation. And what is happening, you can see this magnet here vibrating, right? So what is happening is that it is being magnetized and demagnetized. What is happening, it has now become an electromagnet. You see? It is now an electromagnet. But before, it has no attraction. When I power it on, it becomes an electromagnet, okay? So that's the same thing that is happening here. When you power on these coils, it becomes like an artificial version of this. So it repels your train upwards, so your train is floating. But now the train has to be pushed forward, okay? Now what happens is, for the train to move forward, this magnetism here has to oscillate. You have to be able to change the polarity of this magnetism. Because when you have similar poles like this, these two attract, not so? But these two repel, not so? They push each other away. So if you have a train like this is a train, these are south poles, north pole, south pole. So what happens is, for you to produce motion from this train, you have to provide a force that will push it. And you provide that using the magnet. So if I bring this magnet here, like this, it is attracting. But when I reverse the polarity, it is repelling, not so? So that is what is used to push the train. So when I put this down here, and I do this, that is attracting, but at the bottom, you can see that it is repelling, you see? The train is moving. You see? So that is the force we are going to use to move the train. We have now achieved
Put the opposite
poles to push the train.
on this.
No, the opposite poles are right at the bottom here.
Okay.
Yeah, so the work of this is to levitate the train. Then we also have to put another magnet on the side here, which we did not do. But for the purpose of demonstration, this is what we had to present within the short time frame. But the magnets are supposed to be aligned here.
It's like trams.
The trans.
Yeah. So what we have here is just a simple demo, but there's supposed to be magnets aligned here also. The ones in front here are supposed to repel. Then the ones in front here attract. And what you have is a resultant forward motion. So that's how it's supposed to move. But we cannot demonstrate that here because the slots are empty. And we didn't have enough time to rewind the propulsion coils, but levit and guidance. Because once this thing has achieved levitation, it has to be guided so that it does not hit the wall. So it also has to be having a unique set of coils around here that opposes the magnetism on this and keeps the train centered. That is a little bit technical, so we could not implement it here because it required complex programming and all that. But for the purpose of demonstration, you have to understand that there's guidance needed here. So when the train is floating above this, because of these electromagnets repelling it up, there are coils here that do the same function as this. But for their work is to propel the train forward. So it causes the train to move forward, okay? Then also, there are also unique other coils that will cause it to be balanced and centered at the center point. Yes. So stopping is controlled by our control station here. Yeah, and this is what is known as a programming board. So it helps us to monitor the operation of the train, where it has got an accident, whether it is maybe there's a power shortage. It's supposed to be monitoring all that. But we could not incorporate it here because we lacked some bit of materials. So in the real life application, this has a monitoring system that helps it to detect whether there's an accident or maybe there's a fire outbreak. If there's a fire inside, it tells us, hey, there's a fire. Please come and what? Service the train, or maybe come and, let's say, work on the train, okay? So that's just the basic part of the levitation, the maglev train. Now we go into the technical part of it. This is our...
Maybe before you go on.
Yes.
How different is it from the current systems?
The current
Because
system.
It's also using power.
It's using
Like
power.
Like the current trains are using electricity.
No, the current trains that use electricity still have the problem of resistance. They run on trucks. They run on wheels. This one here floats on top of the truck. So it is the highest speed it has ever been recorded at is 603 kilometers per hour. And that is like traveling from Gulu up to here within 20 minutes. So that's like how fast it can go.
This is what it is projected to do.
Yeah, yeah. And on top of that, it uses purely electricity. It uses purely electricity.
Okay.
The electricity itself is clean, so this eliminates the problem of pollution. You know, there's pollution happening. So the main objective behind this is environmental friendliness.
So the other question is, this looks to be very costly, because we are going to line up these things across the distance from Gulu to Kampala. Will it be economically viable?
When it comes to economics, this is going to be really projected because this is really expensive. It's a very, very expensive system. But that doesn't stop us from exploring the potential behind it. Yeah.
Yes, more like
Yeah.
like these trams, city like commuters.
You can reduce pollution using this system. Yeah. Yeah. City service, yes. So I'm going to do a little bit of demonstration here. Yeah. So the train itself, you know that it's levitating above the track. But now it is not receiving power from anywhere because it's not allowed to touch anything. So it has to receive electricity in some way, and that's where the wireless power transfer comes in. So it uses wireless electricity for the purpose of its operation. So I'm going to demonstrate the wireless electricity transfer here. So what we have here, this is the transmitter coil. And this is usually put in the middle of the truck here. We could not do that because our trucks were dictated by the shape of this core here. So we just had decided to put it on the side. But this transmitter here sends electricity wirelessly to this receiver coil here over a very great distance. And we can demonstrate that by charging it up. Okay, so I power it on, then I turn on. You can see the bulb is lighting. The bulb is lighting.
Same applies to these electromagnets. When you place it to this pole, it will show you that it's the North Pole because it's lighting green. And when you place our train here, it will obtain repulsion because like poles repel and unlike poles attract. So we tested all these inside poles and they gave us North Pole. And same applies to this, it gives us the North Pole. Meaning when this repels this, it will cause it to float and we shall obtain levitation of the train.
Thank you very much.
In the first stage, we inject in our dry maize. So, in the first place, here we are having our motor. This motor will cause the rotation, whereby grinding this dry maize and out this chamber. So, our objective is to make the pellets. So, after getting the dry maize bran, we come and mix with the binder, which is water. We come and inject it inside here, such that we shall connect a belt here to the motor that will cause rotation, whereby compressing the binded grains, forming pellets to the chicken.
The pellet maker.
Yeah, that's the objective. It's a multi-purpose.
So the final product gets out there.
Exactly, that's the main objective. Yeah. Exactly.
So, how is it transported from this side to the other side? The material? No. The material which is crushed, how does it come in? Then you pour it.
Yeah.
So what they're telling you is plan to have a conveying system in the next
A conveying. So,
so that what you process, you feed in there direct.
Yeah.
We can advance on this in case we have given these funds
for commercialization.
and it is working.
So now, what is because we already have
No, it has not been there.
Actually, this one, the crushing element is actually cheap compared to what is on the market. Because building this one, if minus the engine, building this one can take us up to around 350. The other one of the Chinese is around 800,000. So if we can multiply these ones, we can have actually better commercial sales. This is much cheaper. Because all we have are steel blades inside, which keep rotating and crashing. Here the Chinese tend to focus on stainless steel, but it's animals. If it's human feeding, like we shall see for the cassava keeper, then we need stainless steel. So the difference here is cost. Because this one, everything inclusive, is around 350,000. Yeah, but it also matters because our farmers in Luwero may actually struggle to get 350. Yet if we have a farmer group, they can be able to afford this one. But in the end, we are looking for better modes of operation and better capacity than what we can produce.
The corn gets off and it's received down. And you move till and the comb is received from this side. So you get it off. No? So you do it. So you continue and you continue till when this way. So it's basic, it's a manual work, but there are some innovations that are coming through so that we can put a motor and it's automized. You just need a switch and it does its work. Welcome.
The challenge we have is we are not at agriculture, so what we've been using to simulate the biogas, we were using a turnover. And when that smoke passes through here, whatever we have here cools. But everything here, we didn't buy it, we molded it from the faculty here, including all these filaments. And yes, everything is originally made from Ndejje University. Yes, and we actually, apart from agriculture, the student who made this was from Zimbabwe. And we were thinking that since it's in the community where they lose a lot of milk due to preservation, it was part of marketing game. Yes, and these ones here, yeah, it's the one which actually saturates and cools. Yes, and again, this one is picking it up to improve it, and he's also working on our biogas cooking. Is the cooking there? Oh, it works, but is it working? Can you demonstrate it? Hey, engineers.
Should have been here already.
Yeah, you proved to us that there's biogas in that chamber. Taina chibiriti. No. There's no fire. Hey, he wanted you to touch to feel that. But the pressure is still low. But he has been developing biogas cooking as well as biogas cooling. He's doing electrical engineering. So Namanya, can you take us through the cooking?
Yes, thank you. So I use this. This is a portable biogas digester. You know, we have a fixed dome. It is what is common with biogas. So for me, I invented what is portable. This one can be movable. It can be transferred from a place to a place. So I use the cow dung, though you can use some other materials. So for me, I use cow dung. I put in cow dung. I put in a sunlight for some good time. It is supposed to be there for 2 to 3 weeks. But for me, because of time, we took time to get funds. So it has been there for only 1 week. That's why the gas is still little. When you expose it to sunlight, when temperatures are high, this cow dung decomposes in absence of oxygen. So it produces methane, of which this methane is flammable. Now this is the methane. I use this tube as a collector or holder. This is now a gas holder. There is gas here. So when you give it time, 2 to 3 weeks, it decomposes. After decomposing, it produces methane, of which this methane is, I tapped it using these tubes. It comes here. Then I collected it using this tube. So this is my gas holder. So from the gas holder, you can connect it to our gas stove. So this gas stove cooks. Because this gas methane is flammable, only that someone bringing the matchbox is not yet here. So this gas is flammable. So we can use it to cook. We can use it to light. It can give electricity. This uses electricity. So when we get funds, like there is a generator, it is called biogas generator. We can use this methane to put it in that. Instead of using petrol or some other things, we use this methane to power that generator. So that generator produces electricity with the help of this biogas. I think that's the thing.
Okay, let's just go through very fast.
A dome or something, station. It's a portable biogas.
This one is.
Until it bursts or what? Causing accidents.
Sorry, it cannot burst because the gas is moving out.
Oh, it is moving and coming into.
Yeah, we can modify this one and use something else as our holder.
This mode for a tile, it will make the tile in a way that this inside part, you put something hard that will be the surface of the top tile that we shall see on the top. So we add on the sand and the stuff we are going to show up on the top, such that with this one, its weight will help in the compressing, such that it may become hard, such that it may become reasonably hard to withstand or to prevent breaking. So after compressing with this, you realize this one is for this hole, such that when you roll it from the under, when you put it under, the more you roll it, it will be coming out like through this hole. It will pull that whole plate on which the tile is, and you'll be able to lift it out when you. So you'll be able to lift it out such that you put it somewhere where it will dry, and you make others.
So the improvement is the heating, eh?
Yeah, the improvement is
because I remember it was the second lockdown when the student had this. We just had to be fair, but he had included a heating component in this machine. So one of our fourth years should be able to do this for the
The
next
only thing
academic
missing
year.
here, heating component.
But
Yeah,
we wanted to
because
see that he would produce tiles.
Yeah, it is for
but they were
tiles.
wet. So we're looking at a fourth year taking it on so that he includes what?
You have to include the heating such that as you're moving, it can be now for drying.
This tile is so big that it's likely to crack. What measures do you have to make sure that it will be so strong? Because the size is so big.
That's why we want to increase the heating. So
Because
that
into heat.
it solidifies from within.
So there's no frame that you introduce within this.
A frame?
A frame so that you hold it strong in one place.
Because we put a mold, then you fit.
I know that.
You can take on this side, yeah. We advise you not
Because this one is so big. Usually, these papers are small.
Yeah. They are tiled.
Those tiles are small, no?
Yeah.
Because the material you use, I don't know how hard they are. This one is so big that it is likely to crack.
Okay. Yeah, they are there. We must always check that size, the appropriate size that can be used everywhere.
which will be the top. We can still partition this particular such that we make like 4 at once. Yeah.
Because mostly when you're doing this, you're looking at the target. What is your target? If it is here and Ndejje, you can even sell in Ndejje University because the size is convenient. It can go everywhere. We have tiles of this size.
So where is the heat? Where
We have to put it down.
Under.
Yes.
So that as you press.
You press,
So
then
what
you
comes
remove.
first? Is it the heat?
The heat you need to
or
heat.
the force?
Like after compressing, you need to heat.
After compressing.
Yeah, you heat. Then after you remove the mold.
The heat should come first.
The mold already you have put.
Have you fried groundnuts? You first put it, you even put in some water, you hear the cha-cha, then you pour the groundnuts.
Yes.
That is actually the mechanism for the tile. You have the heat, when you add this material there, it helps in the bonding. So the compression is actually just increasing the strength. So the heat should be there, it should be actually simultaneous. But that when you press, it's already,
Heated.
the heat has already spread through the what? The material.
Your work is, it's a sewing machine. So a sewing machine like a saw. The way we see hacksaws, what? So here we designed that you can just sit and do it manually instead of using hands. So here you can just, it's a matter of putting your workpiece here, put a supporting device like a bench vise or a G-cramp, hold your workpiece here. Then as you can sit, just cut, as long as you have done your markings. Yes. It is not supported.
So we are supposed to have
A G-cramp or a bench vise to hold the workpiece here. It should be firm.
You can demonstrate a bit. Use the word.
So the only thing is making the thing fixed using those supporting devices like those machines. Yes. Instead of using hands, what?
So I hope the students are getting feedback from the viewers, which you're going to note down and improve these machines. Yes. So every comment they've made is in good faith. Please take it seriously and improve these projects. Because remember, I want to go commercial.
For this cause, I'm the president of Ndejje University Engineering Students Association, the association that is responsible to bond the students' body with the top administration body at the university level. So first of all, the objectives of this association, me as a president, we have a number of objectives that we have to achieve for the betterment of the students, and one of them would be enabling them to excel academic-wise and be the first priority in the world of market. And how could we achieve this? We have programs that bring up exposure to these students. Part of these programs would be internship that is always rendered to students at the end of each academic year. And we have research activities that always carried out at each and every end of the first year. So these activities bring exposure to students and they give them these practical skills to enable them the priority of the job markets. If I can talk about the university at main campus finds engineering as a niche of all the education academia. Why? This is where we have the name of the institution built, and it takes us a mile to always do the needful, to do activities that can really push us to greater heights in the country. Today being the World Engineering Day, as the institution, as NWESA, as Ndejje University Engineering Students Association, we felt it essential, if at all we celebrated and have these exhibitions on such a day, whereby we participate in the World Engineering Day of 3rd of March, that is going to have its conference run tomorrow, 4th of March at Africana, which is organized by Engineering Registration Board, that is ERB in Uganda. So, doing this exhibition, because today we had 2 events, and one of them was launching of the Faculty of Engineering and Survey Research and Innovation chapter, and this research is under NWESA office, whereby we are aiming at receiving opportunities from the outside world that can benefit students and build their career development. So this is aimed at mentorship, whereby it is mentoring students to achieve the best they would require in their academics. And another thing I can talk about, we as the association always bridge a gap between the institutions of engineering in the Uganda, such that these students, by the time they graduate, they don't have a lot of luxury moments or the lagging time in the field searching for jobs here and there. So we merge them to these institutions such that it bridges them an opportunity to have these activities and they fit into these working environments. And what I can add for the students all over, I can talk of Makerere, Chambogo, and engineering at large. We have a tendency of the final year students doing research projects that are related to narrating problems that are being faced by the world, rather than designing systems that are aimed at solving these challenges that we have. So I do urge the systems to be onto these targetful topics. As we have been told, we have the renewable energy related projects, we have water related projects, agriculture related projects, artificial intelligence related topics, and these topics are going to have the benefit of the community and really solve these community-based problems. I think what I can add on those projects, we have a tendency whereby lecturers or doctors, people pursuing further studies, undertaking the research projects that are being developed by students. And this is a habit that has been developed in Uganda here, and we opt for patent rights for these students such that they can have ownership of these projects after their production, and they move on with them to help them in further studies. That's all I can say for this, and I remain Agaba Tumukurate Evans, the president of NWESA 2022-2023.
Mr. President, before you actually go,
yes.
Talk about the challenges faced by engineers. How have you helped these young engineers as a person, as a chairperson, to overcome these challenges?
First of all, if I can air out about how helpful I've been in this regime of mine, I've found myself an inquisitive, a passionate person, to the extent that I'm there to volunteer at the benefit of students. Volunteer in a way that you sacrifice your time, you sacrifice yourself to make sure that you have lobbed enough sponsorship, you have lobbed enough opportunities for these students. Be it in the engineering institutions, I do take my urge, take it upon myself, move to those institutions, lob these opportunities that are aimed at the benefit of students and bring them to the exposure of students such that they can benefit them in their career development.
What inspired me is, first of all, seeing us as engineers, the urge to develop and contribute to the university in terms of the research and innovation agenda, and also to contribute to Uganda and beyond. What inspired me was to help my fellow students be able to be exposed in terms of research and innovation, research activities, mentorship programs that will expose them to contribute, that will expose them and improve on their skills. Skills such as presentation skills, critical thinking skills, such skills that will help them do things that will improve on the university's research and innovation agenda. We've successfully launched the Research and Innovations Board under the Faculty of Engineering and Survey, and we believe it's the beginning of the great innovations in Ndejje University and Uganda.
The Research and Innovation Board is making research the culture of the faculty. It has been the biggest gap we had in our teaching and learning. Practicals we are fine, labs we are fine, but getting a problem, say from the field, researching about it at the faculty, getting a solution, then sharing it back to the field to see whether it applies, then coming back to the university to improve it, has been a gap. So the biggest thing we are bringing on board is research and development, which they call R&D, where university is of value to society. How do we do it? If we have a rainwater problem, say flooding, then students may have to research that area whether we can have rainwater harvesting. If that does not work, they do it, maybe we have a reservoir, we see whether we can trap that water. If flooding still occurs, the students are going to come up with the concept of a valley dam for that area. It's still from the university, because the university is the center of research, while the society is the center of application. So the Research and Innovation Board is making research and development the core of the Faculty of Engineering and Survey. It also includes things like mentorship, because most students are complaining, you tell us to research, but what are we researching? So from year one, we are going to tell them that every time you have a problem, you read about it, you find a potential solution, you've begun as a researcher. And some students come when they are interested in maybe roads, but every area they have is buildings. So we mentor them into where their strengths are. For example, I'll give you an example of my own self. My strengths are in materials, but not all materials is in clay. For my PhD, I wanted to do steel, until I talked to a professor and he said, go in your strength. And actually, I'm progressing very well because I'm researching clay. So that is the purpose of mentorship.
I want you to talk about the ownership of these innovations. Because when students live in Ndejje, they will grow with these innovations. What do you talk about that? Is it supposed to stay within Ndejje as the owner, or the student goes with it?
Actually, all the student goes with is a degree. Any machine that you have seen, any innovation is the property of the university. One, we build these projects with the supervisors. So the only way the university benefits is the product remains with the institution. However, sometimes students want to go commercial. For example, the banana peeler has won a grant. There's no way, if this peeler is, if it puts the student at another level, that we shall hold on to it. We give them this freedom to expand on it as they return the 10% on each project that the university has. We have been selling groundnut shellers to Arua. There's a technical institute there. The university gets 10%. Then the student who has made that machine gets the rest of the money. So we wouldn't want to be selfish. Otherwise, we'll discourage the others who think, after all, we are making for the university. So we have a system that tends to keep marketing the student with their product. What else we would like to say is, this is a good day. It's a World Engineering Day, and the biggest faculty in the country. There's no university in the country with 2,329 students. It's only this university. So on such a day, if that university can launch a research and innovation board, then it is good for the country. Because today, the country has got 2,329 researchers or innovators. That is what I want to tell the viewers.
Today, we have been launching the Ndejje University Engineering Board for Research and Innovation, and I've been with many young people in the engineering program, and we've been looking at the different innovation and projects that the young people in the engineering program are coming up with, exciting ideas and innovations that are going to add a lot of value in the areas of production in agriculture, in industry, and also new innovations that are very exciting, especially as we move forward in the development of our nation and the world at large. So we are excited as the engineers are celebrating the World Engineering Day. We are also part of this, and we are happy that the dean and the students in the engineering program have done a lot of work, and we really pray that all these projects may come to yield very good fruit that will enhance our industrial development and also move forward our nation in terms of growth and development. Yes, because we at Ndejje University see our engineering program as one of our niche programs. We are very, very excited and also very, very strategically focused on ensuring that the program grows in terms of research and innovation. And therefore, we encourage students to engage more in this innovation and creative ideas. And so we have put aside a fund that will go into the new ideas generated by staff and students. And there we have provided innovation seed money. This is on the budget, and it will go to the best two performing projects that will be presented by the students and staff. So we are encouraging as many young men and women to participate in this creativity and innovation, because at the end of the day, this is what we are expected to produce as a university. Research and innovation is very, very important. And so I encourage all members of the engineering faculty to come on board. I also encourage other members of the faculties in other faculties and departments to also take this opportunity to participate in all sorts of research, innovation, and creativity, especially research that speaks and addresses community needs and even in our locality. We are ready to provide this seed money, and even the seed money will help to build a base. Once you come up with a good innovation, a project, you may even be blessed, and it may even get a global grant or an international grant. So we really encourage you to make use of this opportunity, because every year we shall be having this seed money going out to those new innovators and researchers. And we want all the faculties to participate in this, and I'll be glad to see the best performers every year, and they will receive their seed money to support in the development of those projects. I also want to emphasize the fact that we are doing this especially for research, grant and innovations, majorly because we want to see all the faculties grow in research and innovation, and even outreach, because we don't want people to come up with innovations that are not going to be responding to community needs. We really need our students to be properly mentored into responding to community needs and also ensuring that they are of value that communities would be happy to receive, and also to help in the mentoring and developing of the skills that are required for our engineering students. Personally, I am very, very proud of the Faculty of Engineering, the far it has come, and even where it is moving. I really see that 10 years from now, I want to see a School of Engineering that is able to contribute to all research and innovation, and also the development of our nation, so that at the end of that day, a person sitting anywhere on the globe will look forward to bringing their young people to come and develop their skills within this school, but also to celebrate innovation that comes from this school. And I'm looking forward to these groundbreaking innovations from our young people, which will actually make us a leading university in engineering, but also a leading nation in innovation, especially at a time like this, when we want to see that we move our nation forward in terms of development in industry, in all levels of sustainability, in terms of environment, and also in terms of ensuring that we manage our planet sustainably, and we bring our populations to a point where they can celebrate life using the resources that God has endowed us with here in Uganda. I thank you so much, and I pray that all the engineers in Uganda may celebrate this day with joy and thankfulness to God our Creator, who gave us the creativity and in whose image we share as co-creators and innovators, and that we may continue being good stewards of this creativity and innovation. God bless you.